In this clip, we'll take a first look at kinematics by looking at definitions of the quantities that are involved when we try to describe motion. So we'll look at the difference between distance and displacement, speed and velocity. We'll try to understand the word magnitude, look at what is an average or an instantaneous quantities. Of course, the acceleration will be very important, and we will finish by looking at what are the characteristics that can define whether an object speeds up or slows down. I guess that you're familiar with already a lot of these terms, so to make it a little bit more interesting, we'll start by asking questions that we will then answer together. So question 1, which of the three paths shown has the longest displacement? Is it path 1, path 2, path 3, or they all have the same displacement? So take a second, hit pause if needed, and then try to answer this on your own. So the answer in here is 4. Let's look at why. So the distance is a scalar, and we know it will always be positive and it's always increasing. Really, it's a measurement of the path taken. So if you want to think about this, every time you take a step, the distance will always be increasing. However, the displacement is a vector, which means that it has both a length and a direction. And it is the straight line distance between the final and the initial position. It does not depend on the road you take, on the path you take, it only depends on where you start and where you end. So if we go back to our example, since we always start from one point and always end at the other point, the displacement for all three paths will be exactly the same. Another example to help you remember this, you can think of a jogger that is running exactly 2 laps around a 400-meter track. If the jogger is doing this, the distance traveled will be of how much? Well, there's 2 laps, each lap is 400 meters, so the total distance traveled will be of 800 meters. However, the displacement, since the runner is just going around the track twice, it will actually come back to the exact same point at the end. So therefore the displacement, although it's a bit counterintuitive, will be of 0 meter. Next question. If the position of a cyclist is 0, does its speed also need to be 0? Yes or no? Alright, pause if you need a bit of time to think. I'll give you the answer right away. So the answer is no. And the best way to show this is probably to find a counterexample. So if we think of a cyclist that is on a racetrack, so the racetrack is going around and eventually the cyclist could come back. So if we label the starting point the 0 position, then this means that every time the cyclist passes in front of this point, clearly its speed will not be 0. So we have a clear example that is showing that the answer is no. Next question, so question 3. Is the following statement true or false? The magnitude of the instantaneous velocity always equals the instantaneous speed. So true or false? Make your choice. I'm giving you 3 seconds. Alright, so the answer of that one is true. And before we can look at the final answer, we have to look at 2 special words that are in there. The word magnitude I want to discuss, and also the word instantaneous. So the magnitude is the size of a vector, right? Basically, it's the vector without its direction. We also call it the norm sometimes of a vector. So it's really an indication of how large is the vector. And then there's the difference between average and instantaneous. The average velocity or the average speed describes the motion over a time interval. So when we're talking of an average, it will always be between 2 times. So between 2 seconds and 10 seconds, or during an interval of 8 seconds. So the word average really accounts for an interval in time. However, instantaneous, like in instantaneous velocity or instantaneous speed, describes the motion at one given moment in time. Alright, so at one instant. So for instance, you could ask for the instantaneous speed at 5 seconds. So when you look for instantaneous, it will be at one moment. The average will be over a time interval. And then there's a difference between speed and velocity. Speed is actually a scalar quantity, and it will be defined as the distance traveled divided by the time elapsed. Alright, so since we know that the distance can only increase and be positive, then the same will be true for the speed. We will know that the speed will always be a positive quantity. Velocity, however, is a vector, and instead of defining it from the distance, we'll be defining it from the displacement. So when we'll be looking at the velocity, we will be looking at the displacement over the time interval. So just as displacement, velocity will be a vector, as I said, so it will have a direction. It's in 1D, this means that it could be positive, negative, 0, so it will depend on the situation, and really to find it, you have to go back to the displacement. So we now have all the pieces needed to be able to answer our question. So if we go back to it, we want to compare the magnitude of the instantaneous velocity with the instantaneous speed. So there's a couple of key things in here. Since we're looking for instantaneous, we want to know what happened at one moment. So at one moment, if we have an object, we know that it will be moving in a certain direction. The distance that it covers and the displacement that it covers, because it's over just one moment, we know that there will be no difference. There won't be any time for the object to turn. When we have a difference between displacement and distance, it's because the displacement is a straight line while the distance can be curvy. But in here, at one moment, the two will be parallel, will be together. So in that case, it is true that the magnitude of the instantaneous velocity will be equal to the instantaneous speed. All right, next question. Question 4. If the velocity of a train is negative, what can be said about its acceleration? 1. The acceleration must be negative. 2. The acceleration must be 0. 3. The acceleration must be positive. Or 4. Not enough information to determine the sign of the acceleration. Again, hit pause if you need time. I'll give you a couple of seconds. So the answer in here is 4. Not enough information to determine the acceleration, the sign of the acceleration. So we have to be careful here. It is generally assumed that the velocity is the sign of the velocity is affecting the acceleration. But actually the acceleration is corresponding or is linked to the change in velocity. So to the variation between the velocity at the final time and the velocity at an initial time. All of these are vectors, of course. So just knowing that the velocity is negative is not sufficient. We need to know how the velocity changes in order to be able to figure out what the acceleration will be. And there are typically 4 different cases, okay? And that's what I want to discuss with you. There are 4 possible sign combination for velocity and acceleration when we are in one dimension. What I want you to think about is which one would result into speeding up and which one will result into slowing down. So again, I'm giving you a couple of seconds to think about it, and then we will look at it together. So what's important in this situation is the relative direction of the velocity and acceleration. You can see that in case 1 and in case 4, both the velocity and the acceleration are pointing in the same direction, while in case 2 and 3, they are pointing in opposite direction. We know that the acceleration is related to the change in velocity. So if the acceleration points to the right, this means that the change in velocity will also be pointing to the right. And since the velocity is always already pointing in this direction, this means that it will be increasing. So case 1 and 4 corresponds to speeding up. And we see this because both vectors, A and V, point in the same direction. That's the case for the cases 1 and 4 up there. And then there are the other 2. So for the other 2, what we have in here are cases where the velocity and the acceleration vector are pointing in opposite direction. So what we will observe is that actually in these cases, the object will be slowing down because the acceleration is going against the velocity vector. So in cases like this, we see that that is the case, it is slowing down because A and V are in opposite direction. That's it. So we have 4 cases, and we can, with this, decide whether an object will be speeding up or slowing down. I also want to take a second to talk about deceleration. Deceleration is not necessarily negative acceleration. Okay, we'll go away from using that term, deceleration, but usually when we talk about deceleration, we talk about an object that is slowing down. All right, that's it for this clip. Remember that after this, I'm expecting you to be able to differentiate between distance, displacement, speed, velocity, use the word magnitude, average and instantaneous quantities, acceleration, and be able to recognize when an object will speed up or slows down. See you in the next clip.